Okay, so first question we're going to look at involves adding two vectors together visually. So all I want to do is take those two vectors and add them. Can anybody remind me how we need to line those vectors up if we want to add them together? Yeah?
You have to put the side of the arrow on one of them and the side of the arrow, not without the arrow on the other.
Okay, so we can line them up just like that. Does it matter if I do that versus that? No, that doesn't make a difference, right? Because vector addition is commutative. Okay, so that's how we line the vectors up. And then can someone else tell me how we draw the final answer once they're lined up like that? Yeah?
You put the initial point and final line where the initial point of like the bottom one is, and then line up the arrow at the top.
Yeah, so we're going to start here. We're going to end right there. And that is the result if you add those two vectors together. Okay, that's how you would sketch it. Any question on that one? All right, so the next one is similar, except it's more of like a true-false. They want to know here, if you add V and W together, is this what you get? Okay. All right, well, let's try that. Okay, what's the first thing I would have to do if I want to see if that's the right answer when I add V and W? Yeah.
You have to line V and W up, and then you can see if the new vector is the same one that they're giving us.
Okay, yep, so we're going to line them up like we did last time. Connect the end point of one with the starting point of the other. All right, so that's what you get if you line up V and W. And now draw in from the initial point of V to the terminal point of W. And when you add V and W, that is the answer. Okay. Is that what they're suggesting? No. So the answer here is, does V plus W equal that? The answer, that is false, or no. This is the correct answer. So however somebody got that one, they lined them up wrong. They were not lined up the right way. Okay. And you don't need X to do this one at all. That's just an extra vector that wasn't used. Okay. Any question on those two? All right. All right. The next question we're going to look at is for 3D vectors, but you might have one of these in 2D as well, is finding a position vector. When we find a position vector, what arithmetic operation do we do with the terminal and initial point? Yep. Subtract them. And what's the order? You do what minus what?
Terminal first minus the initial.
Terminal minus initial. Yep. Okay, so we're going to subtract terminal minus initial. Right, so if we want to do it, we'll do this notation first, and then we'll change it to ijk. What's going to be the calculation for my x-axis component using those terminal and initial points? Yeah.
5 minus 4.
5 minus 4. Okay, so that's the first one. How about my y-axis component? Yeah.
Negative 8 minus 2.
Negative 8 minus 2. And the z-axis component?
7 minus negative 3.
7 minus negative 3. All right, so that's going to give me 1. Negative 8 minus 2 is negative 10. And 7 minus a minus 3, that's going to become plus 3. So that's 10. Or if we put that in ijk notation, how would that look? Yeah.
I minus 10j.
10j.
Plus 10k.
Yep. So the only thing is if you're doing it in 2D, you wouldn't have to worry about k. So I minus 10j plus 10k. Any question on finding a position vector given two coordinates? Yes?
Would it be wrong to write it as I plus negative 10, or is that okay?
If you put plus negative 10j, that would also be okay. Yeah. All right, so that's position vector. Next one, we're going to do two of them. So we're going to use the two vectors v and w, and we're going to add them together, but this time not visually, just numerically. And then we're going to scale the vector, also numerically, not visually. All right. And since they gave us the original problems using unit vector notation, we'll do our answers the same way. All right. When we add v and w together, anyone think they could give me the whole thing? Yeah.
So 3i plus 5i.
Yep, and that would be
8i.
8i.
And then 2 minus 8, so minus 6j.
Okay, so minus 6j.
And then negative 4 plus 9, so 5k.
5k. Okay, so that's what you get when you add the two vectors together, just combining your like terms. Now scaling, that's an operation you only use one vector. You're not going to use w at all to find 4v. What would we get in unit vector notation for 4v? Yeah.
12i plus 8j minus 16j.
So 12i plus 8j, so we multiply the i component by 4, the j component by 4, and the k component by 4. So that's scaling a 3D vector, and you may also have to scale a 2D vector. You just won't have to worry about k then. It's just I and j. Okay. Any questions on those two? Okay, so next question we'll look at is finding the magnitude. When you're finding the magnitude, we always want to start out with that symbol, okay, because it's going to be the square root of, and then something. Okay, does anybody remember the first thing we put right under the square root when you are finding the magnitude? Yeah.
The first term squared.
First, yeah, just the coefficient of it. So it's 2 squared. And what comes immediately after that? Yeah.
The second term squared, you add them.
You add them. Yep. So plus sign, and then the second term squared. And if it was 2D, you'd be all done. But we need one more thing here. Yep. Plus, and then 3 squared. Yep. All right, so let's do that out. We're going to get 2 squared is 4. Negative 9 squared is 81. And 3 squared gives us 9. So as an exact answer, that's going to be the square root of how much? Yep.
94.
94. Okay. Any question on how we got the magnitude? Okay. So the next one we're going to look at is finding a unit vector. So remember, a unit vector is a vector that points exactly the same way as the one that I give you, but it's only 1 unit long. That means you may have to take the vector I gave you and shorten it, or you may have to lengthen it. But when you're done, it has to be 1 unit. Okay. To make this vector 1 unit long, what do you have to know about this vector first? Yeah.
The magnitude?
Yeah, we need the magnitude. So you know what? We should probably just, I guess we could have done this one because we got to find the magnitude again. But I made this one come out a little nicer. It's a 2D problem. And it's going to be just like we did. Square the first number. Square the second number. And add them up and take the square root. So what's the magnitude going to come out to for 3i minus 4j? Yeah, 5. So we now should be able to answer the question, is what I gave you a unit vector? What do we think? 3i minus 4j, is that a unit vector? Well, what does it have to be a unit vector? What makes something a unit vector? Yeah?
Having a length of 1.
Having a length of 1. So what's the length of that?
5.
5. So is that a unit vector? No. So it's 5 times as long as it should be. So what are we going to have to scale the vector by to shrink it down to 1 unit long? Yep.
1/5.
1/5. So we need to find 1/5 v. If we scale that vector by 1/5 and leave our answer as fractions, what would be the vector that is 1/5 as long as that? Yeah.
3/5 I minus 4/5 j.
Yeah. So that's a scaled down version of the original. Still points the same way, but we made it 5 times shorter. So now we converted it into a unit vector. So 3/5 I minus 4/5, and that's a j. It's not a good j. Any question on that? All right, so that's finding a unit vector. Okay, next two. Finding a dot product, and then we'll also use that to find the angle. And again, this could be a 2D problem or a 3D problem. I picked a 3D. All right, so first thing, can someone remind me, what is the formula to find the angle between two vectors? Yeah.
Cosine theta equals u dot v over the magnitude of u and the magnitude of v.
Okay. So this combines some of what we just did in the last two. We got to find the dot product, and then we have to find the product of the magnitudes. Okay. So let's start with, in our case, we're calling them v and w. In the formula, we used u and v. It's just a different name. But let's start with the dot product. All right. What's going to be my first calculation in the dot product? Yeah.
It would be the 3 times -2.
Okay, so 3 times -2. All right. Next calculation? Yeah.
-2 times 7.
And what are we going to do with that and the previous one? Add them. And one more calculation there to complete the dot product. Yeah, Lauren.
8 times -4.
8 times -4. All right, so let's do that. We get -6 minus 14 minus 32. All right, so -6 minus 14 gives me -20. Oops. And -20 minus 30 gives me -52. Okay, by getting a dot product of -52, there is one thing we know about the angle between the two vectors right now. What do we know about the angle? So this -52 tells me that the vectors are not something. Yeah?
Not orthogonal.
Yeah, they're not orthogonal. Okay, because if they were orthogonal, I would have gotten a dot product of 0. So I know they're not 90. Okay, so we got the dot product. Now we need the magnitude of V and the magnitude of W. Okay, we just did the magnitudes before, so we'll go through that kind of quick. So you square each number, add them up, and take the square root. So it's going to be 9, 4, 64. Okay, and that's going to give me the square root of how much for the magnitude of V? Yeah.
77.
Square root of 77. Okay, and I need magnitude of W. That's going to be square each number, add them up, and take the square root. 4, 49, and 16. 4 and 16 gives me 20. 20 and 49 gives me square root 69. Now, we've got the magnitude, we've got the dot product. Fill them into the formula that's up above. Okay, so cosine theta equals the dot product over the product of the magnitudes. 77, 69. Now, what's on the right-hand side? That's not theta, that's cosine theta. How do we get theta instead? Yeah.
Take the inverse cosine.
Yep, take the inverse cosine. Okay, so on your calculator. Okay, as we type that in, just be careful with parentheses. So inverse cosine, negative 52 divided by, and I'm going to put the denominator in parentheses because there's two factors there. So square root 77 and times the square root of 69. Because they're both square roots, you could have just done the square root of this in the bottom. You are allowed to do that. Okay, so that would have avoided needing an extra set of parentheses. All right, so inverse cosine, I think that looks good. 135.51. And that's the angle between the two vectors. Okay, any question on finding dot product, magnitude, or angle? Okay, so next question we'll look at is finding the distance between the 2 points. So remember in 2D, find the difference between the x's, find the difference between the y's, square each distance, add them up, and then take the square root. Just like most of the formulas we extended to 3D, you just have to extend that to 3D by doing a z2 minus z1 squared. All right. So let's find our distance. Okay, set everything up. Just like that. And what's going to go inside the first set of parentheses? Yep.
-2 minus 0.
So we have -2 minus 0. Okay, my second set of parentheses. Yeah.
1 minus 4.
1 minus 4. And third set. Yeah.
9 minus 5.
9 minus 5. Okay, when we simplify, we're going to get -2 minus 0 is -2. And what's -2 squared? Yep.
4.
So we get 4. 1 minus 4 squared will give me
-3 squared is 9.
just 9. And 9 minus 5 squared gives me, yeah, 16. Add it all up. 4 plus 9 gives me 13. 13 and 16 gives me 29. So that's the distance between those 2 points, square root 29. Okay. Any questions on that one? All right. So the last one. This is a concept that only applies to 3D. That's the cross product. Okay. First thing is we learned earlier today, well, depending on when you're watching this video, when you do the cross product, does the order make a difference? Yeah. So we want to make sure we set it up as V cross W. All right. So we're going to use that rule, okay, Saris's rule. And when we set up our matrix, what's going to go in the top row? Yep.
I, J, K, I, J.
So I, J, K, I, J. Yep. So there's your top row. What's going to go in our second row? Yep.
2, 3, negative 4, 2, 3.
2, 3, negative 4, 2, and 3. And how about our last row? Yeah.
Would it be negative 1, 1, negative 5?
Negative 1, 1. Negative 1, 1.
Negative 5, negative 1, 1.
Yeah. Okay. Now we got to look at some diagonals. How many diagonals are there that we have to look at? Yep. 6. Okay, it's 3 that go down and to the right, and then 3 that go down and to the left. Okay, so we'll start with that one, and that one. And then we'll take a look at that one, and that one. Okay, when we do the 3 that go down and to the right, what kind of arithmetic do we do with those 3? We're going to find all 3, and then we're going to add them. Yep. Okay, so down and to the right, what's I times 3 times negative 5? Yeah.
Negative 15i.
So we get negative 15i. How about j times negative 4 times negative 1? Yeah.
4j.
And we're going to add that. Okay, so I want to fill in my symbols so I don't get confused. This is what we're doing. I don't know whether I'm going to get a positive or negative inside the parentheses, but I know I'm adding the first 3 together and I'm subtracting the last 3. Okay. And then what about k times 2 times 1? Yeah.
2k.
2k. Okay, so we got that one, we got that one. So that's the 3 that go down and to the right. Now do the 3 that go down and to the left. What's k times 3 times negative 1? Yep.
Negative 3k.
That's a negative 3k. What about I times negative 4 times 1? Yep.
Negative 4i.
Negative 4i, and you're subtracting that. And j times 2 times negative 5. Yep.
Negative 10j.
Negative 10j. All right, so it's actually going to end up all being added at the end because we're subtracting negatives each time. I guess there was 1 negative on each of those diagonals. Yep. Okay, so we have negative 15i minus 4i. So that's going to be plus 4i. What are we going to get when we put all our i's together? Yep.
Negative 19i.
So it's not negative 15 minus 4, it's going to be negative 15 plus 4.
Negative 11i.
Negative 11i. Okay, so there's our i's. How about the j's? 4j minus 10j. Yeah,
14j.
14j. And the k's, 2k minus 3k. Yeah,
Plus 5k.
plus 5k. And that is the cross product. Now, one way you can quickly check is if you find the dot product between that and either of the original vectors, it needs to come out to 0. If the dot product is not 0, you did something wrong. So if we multiply negative 11 times 2, that's negative 22. 14 times 3, what's that, 28, 42. And 5 times negative 4 is negative 20. Negative 22 and positive 42 is 20. 20 minus 20, 0. So, I mean, it doesn't guarantee that it's right, but it's probably pretty likely that now it is right. And you could check the dot product with this one as well. That would be 11 plus 14, and that would be minus 25. 5 times negative 5. 11 and 14 is 25. Perfect. Okay, 25 minus 25 is 0. So that means this vector is perpendicular to both of the original ones, and it always should be. Right. Any question on finding the cross product? Okay.